Hello learner, my name is Dickens and we are talking about salts. Under salts, we want to talk about solubility of bases for this lesson. And I want us to start by reminding ourselves what is the meaning of this word base. So as we learned in Form 1, we said a base is a substance that reacts with an acid to form a salt and water. So we are saying a base is a substance, any substance that reacts with an acid, to form a salt and water. That is the definition we got in Form 1. And we need to know this, learner, that bases are of two types. Bases can either be a metal oxide or a metal hydroxide. So we are saying bases are of two types. Bases can either be a base can be either a metal oxide, or metal hydroxide. We are saying so because, for example, if you react a metal oxide like zinc, for example, if you react zinc oxide with an acid such as hydrochloric acid, you'll get a salt, and our salt will be called zinc chloride plus hydrogen plus water. So we are saying zinc oxide is categorized as a base because it reacts with HCl to form a salt and water. These are metal oxide. Then we can still react zinc hydroxide with, for example, nitric acid. We shall get a salt, and our salt will be called zinc nitrate, and then plus water. So you can see from the definition of a base, we have said a base is any compound which when reacted with an acid will form a salt and water. And we have said a base can either be a metal oxide or a metal hydroxide. So these two, zinc oxide, when reacted with HCl will get a salt and water. If you also react zinc hydroxide with nitric acid, you'll still get a salt and water. So therefore we are saying bases are either metal oxide or metal hydroxide. So having said that, we want to look at how do they behave when they are dissolved in water, and we shall do that by way of experiment. So we are going to have an experiment here. Give you brief procedure. So our first procedure is you put about 20 centimeters cubed of water in a boiling tube. You can measure that using a measuring cylinder. Then number 2, you add half a spatula full of sodium oxide, and shake. So we take sodium oxide, half a spatula, and then we add it to the boiling tube containing water. After that, you shake the mixture. We are simply shaking to make sure that the salt, the base will dissolve in water. Thirdly, you repeat the procedure using the oxides of potassium, calcium, magnesium, aluminium, zinc, and copper. So instead of having sodium oxide, you replace sodium oxide with potassium oxide in the second experiment. You also try with calcium oxide, also try with magnesium oxide, aluminium oxide, zinc oxide, and finally copper oxide. Then our last procedure is you now repeat using hydroxides of potassium, sodium, magnesium, calcium, aluminium, zinc, and copper. So you now replace, instead of using the metal oxide, you now change and use the metal hydroxide. So you'll use the hydroxide of potassium, first one, potassium hydroxide, sodium hydroxide, magnesium hydroxide, calcium hydroxide, aluminum hydroxide, zinc hydroxide, and then lastly copper hydroxide. You dissolve in water. Then after which you test the resulting solution. In each case, using litmus papers. So you'll have two litmus papers, the blue litmus paper and the red litmus paper. After you're through with the procedure, you record your results. Record your results in the table below. So our results will be recorded in the table as shown below. So we'll have our table of results. In the first column, we shall put our cation there. Then the second column we divided into two. So in the second column we shall mention here the solubility. Then here we shall have effect of resulting solution. So here, remember, we are dealing with bases, and we have said bases are either metal oxides or metal hydroxide. So here the first part will be the solubility of metal oxides, solubility. Then here we shall put the solubility of the metal hydroxide. Then here the effect of the resulting solution, effect of the resulting solution of the oxide, then effect of the resulting hydroxide. So here we shall put our cations. From the procedure, we can be able to identify the cations that we are using. Remember, we said cations are positively charged ions. So our first one from the procedure will be potassium, so that our oxide is potassium oxide, the other oxide is potassium hydroxide, and the next one is sodium. So the oxide is sodium oxide, sodium hydroxide. The next one is magnesium. So we shall have magnesium oxide, magnesium hydroxide. Next is calcium. Same, calcium oxide, calcium hydroxide. We shall have aluminium. We shall have zinc. And lastly, we shall have copper. These are the cations that we are investigating, whether their bases are soluble in water or not. So now we are saying that these are the expected observations, that potassium oxide, when it's dissolved in water, the result will be, it's going to be soluble. So in our table, we are saying potassium oxide is soluble in water. The same applies to potassium hydroxide, is also going to be soluble in water. We come to sodium oxide, it's also soluble in water. Then sodium hydroxide is also soluble. We come to magnesium oxide and magnesium hydroxide. These two are slightly soluble. That means if you put magnesium hydroxide in water as well as magnesium oxide, part of it will dissolve. That's why we are saying it's slightly soluble. The same applies to calcium. Both calcium oxide and calcium hydroxide, it's also slightly soluble. Slightly soluble. Come to aluminium oxide and aluminium hydroxide. So we need to know that the oxides of aluminium and the hydroxide of aluminium, the two are insoluble in water. Therefore, our observation is it's insoluble. This one is also insoluble in water. It will not dissolve. The same applies to zinc. Zinc oxide is insoluble in water, as well as zinc hydroxide. Copper oxide, the same thing, is insoluble in water, as well as copper hydroxide. So we now look at the effect of the resulting solution on litmus. Remember, we said you're using litmus, and litmus is either blue or red. So the two, we are going to drop the two litmus papers in the resulting solution. For example, we have said potassium oxide is soluble in water. So we are saying you take the resulting solution and then you drop both blue and red litmus paper into that boiling tube containing the solution formed by potassium hydroxide dissolving in water. So this will be the expected observation, that the oxide of potassium will dissolve in water to produce a basic solution. And a basic solution, you know very well that it will turn red litmus paper to blue. So that's what we put in our table here, that the resulting solution turns, so it turns red litmus paper to blue. So that's why we are saying that the solution is going to be a basic solution. So we are saying that the oxide of potassium, when dissolved in water, the resulting solution will turn red litmus paper to blue. The reason we have said is because that solution is a basic solution. The same applies to potassium hydroxide. that the hydroxide that will be formed if you test using litmus paper, the litmus paper will turn from red to blue, meaning the resulting solution is a basic solution. So the observation will be the same, that it turns red litmus paper to blue. That is potassium. The same applies to sodium, that sodium oxide, we have said it's already soluble. So the resulting solution is a basic solution, and that solution is called sodium hydroxide. So if you test sodium hydroxide using litmus paper, it will also turn from red to blue because that solution is a basic solution. So the observation will be the same. So we are saying it turns red litmus paper to blue. The same applies to sodium hydroxide. The resulting solution will also turn red litmus paper to blue. We have said magnesium oxide as well as magnesium hydroxide is lightly soluble. That means part of the solution formed will be basic solution. It means if you test that solution using litmus paper, it will still turn despite the fact that magnesium hydroxide is slightly soluble. So the observation will also be the same. So we are saying that the resulting solution will also turn red litmus paper to blue. Also here, the hydroxide will also turn red litmus paper to blue. We are saying because magnesium hydroxide as well as magnesium oxide is lightly soluble, so part of it will dissolve. The same applies to calcium. It will also form a basic solution, and that solution we expect it to turn red litmus paper to blue. So same observations, it will turn red litmus paper to blue. Also this one turns red litmus paper to blue. We're saying the reason is because there is formation of a basic solution. So here the basic solution formed is called calcium hydroxide. Here we form magnesium hydroxide. Here we form sodium hydroxide, and then here we form potassium hydroxide. Now that these three are insoluble, then it means we shall not form any basic solution. As a result, the resulting solution will not have any effect on litmus paper because the solution is neither basic nor acidic, because of the fact that both aluminium oxide and aluminium hydroxide are insoluble. That means we shall not form any basic solution. Therefore, the effect of the resulting solution, there is no effect. So that will be the observation, that there is no effect of the resulting solution on litmus paper. The same applies here. No effect on litmus. No effect on litmus. The same applies to zinc because the oxide is insoluble as well as the hydroxide. Therefore, there is no basic solution, and for that reason, there is no effect on litmus. No effect on litmus. The same applies to copper. We can see from the table copper oxide is insoluble as well as copper hydroxide. Therefore, we shall not form any basic solution. So no effect on litmus. No effect on litmus. So learner, we can see that we have some oxides and some hydroxides which are soluble, others are insoluble. Those which are soluble they form a basic solution. So for the case of sodium, the reason why the resulting solution will turn red litmus paper to blue is because of formation of a compound, and that compound is called sodium hydroxide. As we can see from the equation, this is how the product is formed, that if you take sodium oxide, you dissolve in water. So we're writing an equation. Sodium oxide is a solid, water is a liquid. So the sodium oxide will dissolve in water, then we shall form a basic solution, and that basic solution is called sodium hydroxide. So this is the solution that will be responsible for the turning of the red litmus paper to blue. The same applies to sodium hydroxide. Sodium hydroxide. Sodium hydroxide. It actually dissolves in water, but it will not react. So the product will still be sodium hydroxide, but in aqueous state. So this one simply means that it is sodium oxide that is dissolving in water to give you a solution, and this solution is basic in nature, the one that will turn red litmus paper to blue. The same applies to potassium, magnesium, as well as calcium. So for the case of potassium, this will be the equation: potassium oxide reacting with water, we shall form potassium hydroxide. Potassium hydroxide, which is our basic substance that will turn the red litmus paper to blue. The same applies to potassium hydroxide. Potassium hydroxide, when it is put in a test tube and then mixed with water, the potassium hydroxide will dissolve in water to give us potassium hydroxide solution. Potassium hydroxide solution, which is basic. So we are saying that the oxides as well as hydroxides dissolve in water to produce basic solutions, and those basic solutions are the ones that will give this solution basic properties. As a result, the solution will turn red litmus paper to blue. So learner, we have come to the end of our lesson, and I want you to try the following questions. Remember, we have been talking about solubility of bases, and we have seen that some bases are soluble in water while others are insoluble. Those which are soluble dissolve to produce a basic solution. We have seen that from the equations. So you try these questions. So our first question is, state oxides which are soluble and insoluble. That's our first question. You'll try that. Second question, state oxides, not oxides but hydroxides. State hydroxides which are soluble and insoluble, of course, in water. And then lastly, state the effect of the resulting solution solutions on both blue and red litmus papers. So that's the end of our lesson for today. I'll see you next time.